Okay, so now I'm recording. Okay, so let's continue our discussion. So let's talk about RC. Okay, RC. We have RC, we have RL, and then we have RCL circuit. Okay, so we have these three, yeah, RC, RL, and RCL circuit. All right. So, okay. So now, so you learn, okay, the thing before. Okay, let me repeat again. So we know that when talk about, okay, we have this RCL. Okay, for this one, the current in phase with the voltage. Okay, resistor. But for current, for capacitor, because it is ice, okay, whereas the inductor is Le. Okay, so we know that for capacitor the current is leading, yeah, current is leading, so its current leads Vc by 90 degree, and then for inductor is VL leads current by 90 degree. Okay, so VL leads current. VL leads current by 90 degree. So we know this. Capacitor is current, inductor is voltage. Remember that, yeah. So okay, remember this. And this one is in phase, yeah, resistor. Okay, so we know that. Then now let's talk about RC circuit. So RC circuit basically is is a circuit with resistor and capacitor. Okay, so of course this one has the V source. We have the VR, and then I have VC. Okay, so okay, we have two component lah. Whereas for let me draw all the circuit first. So this one we have resistor, inductor. Okay, then for RCL it is the resistor, capacitor, inductor, all in series. All in series. We never talk about parallel. All in series. So okay, so this one we have V source. This one we have VR, VL. Okay, and then this one also V source, VR, VC, and VL. Okay, so we can say all of the voltage is the different lah. They all have different voltage, but current is the same. Current is the same for all. Yeah, current is the same for all because current travel the whole circuit. Understand, class? The current is the same for all. Okay.
Yes, sir.
What I mean is the current passes through all the component. They all have the same current as the current in the circuit because they are series. They are series. But the voltage is different. V source different from VR, different from VC. Okay. Now the question is how to find the V source. Okay, and also how to find the total impedance. Yeah. So how to find because this one is we have resistor and XC, and what is the impedance for everything? Yeah, impedance is the whole thing lah. And then this one is between R and XL. Yeah. So okay, let us do it one by one. Okay. So again, so hold on a second. Okay. So how should I? Okay. Okay. All right, class. So I shall begin now. So wait a second. I need to adjust the whole thing. Yeah. Wait. Okay. It's too crowded. Okay. So let us a little bit, okay. Just like this thing can zoom in and zoom out. Okay, so sorry for delay. Now, so let us begin with phasor diagram. Okay, I'm going to draw a phasor diagram. So, so for RC circuit, so all of this, okay, all of these, we let the current sits at, X first. We let the current sits at here. Understand? In fact, I want to add one more. Yeah, for the whole thing. Yeah, I want to add one more here. Okay, so now let us look at RC circuit. Yeah, first we look at RC circuit. Okay, when talk about RC circuit, resistor and capacitor. So resistor, the current in phase with the voltage, resistor. So we see current at the x-axis. So we can say also the VR is over here. Understand? VR in phase with current. Okay. So they rotate together lah. Voltage, resistor, and current rotate together. Okay. And then we have capacitor, right? We have capacitor. So capacitor is current leading by 90 degree. That means if current is over here and this is a rotation anti-clockwise, so that means VC is below. Okay, VC is below. Current leading by 90 degree. So it's 90 degree lah. See, this current in front of VC, but correct or not, class? Current in front of VC, is that correct?
Yes, sir.
Yeah, I need response. Respond, please be quick because I don't want the video to be too long. Yeah, then the video will be boring. Okay, now, so we use this phasor diagram like vector diagram, like vector. You understand? Vector. So how to find the V source? We just Pythagoras theorem. That's the V source lah. Sometimes we write it as, we say V supply, voltage supply ataupun V applied. Another name lah. Another name for voltage source. Okay, voltage source is like voltage supply or voltage applied. Okay. So we have VR, VC, so V source, this one. Okay. So how to find the V source? Very simple. How? This V source is the total voltage lah. The total voltage for VR and VC, but we cannot say it's not equal to VR plus VC. Cannot. Understand? Because this is only for DC. Understand? DC boleh tambah begitu, tapi for AC, what you have to do, class? You have to do phasor diagram. You have to do this like vector. Is because they're different phase. VR is 0, but this one is negative maximum. So you have to square and square root. Is V source is equal to this square root. It's not equal to direct add up. Understand, class? If you want to get the value of V source, you must do Pythagoras theorem, not straight away add up. That is for DC. For AC, you need to do this one. Understand? And we also can translate this, if you either can use the peak value, or you use the root mean square value. Either you find the V naught or V RMS. Understand, class? Okay,
Yes, sir.
Understand, Okay, Okay, so if you use peak value or peak value, if you root mean square value, then we all root mean square value. Yeah, that's to find the V source. Now, how about to find the impedance? How? Same thing. If VR over here, so that is the same position for resistor. That's the same position for resistor. And then VC over here, that means same position for XC. So V source over here, that's the same position for Z. Okay. So how to find Z? So again, Z is not equal to R plus XC. Understand? Is not equal. How to find Z? How to find Z, class? Tell me. Pythagoras theorem. Understand? Like that only. Okay? Then you can find Z, the total impedance for the whole circuit, for AC. Very easy, isn't it, class? You know vector diagram, then you must know this already. Pythagoras theorem. Okay, one more thing, class. One more thing. Here you have phi. Here you can find the phi. Okay? That is what we call, phi is what we call the phase angle between current and V source. Current and V source. Current and V source. That's the phase angle. So if you see like this, you can see who is leading. Who is leading? Current or V source? Class, rotation anti-clockwise. Who is leading? Current leading or V source leading? Current leads V source. So for RC circuit, let me highlight it. For RC circuit, it is current leading V source by phi radian. Understand? So this phi radian can be any degree lah, 30 degree or 60 degree, anything. Yeah. So current is faster than V source. Not 90 degree. Yeah, it's not 90 degree, but but less than 90. Why? Because we have resistor. And why is it current leading? Because we have capacitor. Because of capacitor kan, so got capacitor kan, it makes the current leads the voltage. Because got capacitor. Understand, class? And it's not 90 degree because got resistor. So it make it less than 90 degree. Okay. Why no respond one? Yeah. Okay, and then one more thing. That's a phase angle. And then we have cos phi is what we call power factor. We have a special name. We call it power factor. And how to find this power factor? How to find? Cos phi is either equal to, is adjacent over hypotenuse. Because cosine, right? Cosine. So it's adjacent over hypotenuse. So it's VR over, we can put it VR or over V source. Or it's also equal to resistance over Z. Sorry. This is resistance over Z. Okay? So this one is can be peak or it can be RMS value lah. Understand? So if you want to find cos phi, the power factor, okay? You take peak voltage for resistor over peak voltage of source. Or you can put root mean square voltage of resistor over root mean square voltage of source. Understand? Or resistance over impedance. Then you can find the power factor cos phi. And then you anti-cos, you can find the phase angle phi. Yeah, anti-cos. That's it lah. And then okay, then now RL circuit. Now let's talk about RL circuit. RL circuit. So again, we have voltage resistor. So we also resistor is current in phase with VR. So same thing. We can write VR over here. Okay, and then we have what else? We have VL. VL is where? VL is what? LE. VL is voltage leading current. Understand? Voltage leading current. So for rotation anti-clockwise, so the voltage VL leading by 90 degree. That means VL must be in front 90 degree. In front 90 degree of current. So VL at over here lah. Understand, class?
Yes, sir.
What is the V source? Here's the V source. Here's the V source. Here's the V source. Okay. Here's the V source. Again, V source is not VR plus VL, but how to find? How to find? Make it green. So V source is VR square plus VL square. You cannot just plus it together like that. Yeah, it's not DC, it's AC. So you must like. So this one, you can either find the peak. You can either use peak value, or you can use root mean square value. I mean, if you use peak value or peak value, if you use root mean square value or root mean square value. Okay, class. Then same thing for if you want to talk about impedance or resistance or reactance. Then you the same graph also. VR is R, VL is XL, V source is Z, V source is Z. Rotation anti-clockwise. Okay. So Z is also the same. You need to do Pythagoras theorem. You cannot just add up R plus XL. Cannot. You must do Pythagoras theorem. Easy or not, class? So easy, Glenn. And then what is phi again? Phi is the phase angle between phi is the phase angle between current and V source. Current and V source. So okay, current and V source. So this one lah. So here we have where is our V source? V source is over, yeah. Always look at these two, class. Always look at these two. Between current and V source. That's where is the phi, yeah. Current and V source. So our phi is always between these two. Between the current and between the V source. Remember that? Or between the current and between the Z. Between current and Z. Because Z is V source lah. Okay, that's the phi. So how to find the phi? Same thing. You just to find, first you find cos phi, kan? You find cos phi is VR over V source, same formula, or R over Z. What is this? R over Z. Okay. If you want to later you want to find the phi, then you just anti-cos lah. Anti-cos. The R over Z. You also can find the answer. Yeah. If you use tangent, also can find. Tangent phi. Then is you must take tangent. Tangent is XL over R. XL over R. But tangent phi is not power factor. Power factor is only cos phi. Power factor is only cos phi. What is power factor? Later in the last part of this chapter, I will talk about it. Power factor, but not now. Yeah. But if you just want to find the value of phi, you can use tangent. You can use sine also, sine phi, or tangent phi, or use cos phi. But since cos phi is power factor, I think better you just stick to cos phi lah. Power factor easy because you can find two things other than only one thing. If you want to find tangent phi, is only you can find the phi lah. In the end, it's just the phi. Yeah. In the end, it's just the phi. Also can, yeah, or you can use sine phi also. In the end, it's just finding the phi. But if you use cos phi, you can find the power factor also. You can find power factor, you can find the phase angle phi also. You understand what I'm talking, class? It's better you find two things other than only one thing. Yeah? You understand what I'm saying about? Talking about?
Yes, sir.
Okay, good. So let's proceed. Yeah. For this one, who is leading? Vsauce leading or current leading? Vsauce leading or current leading? Vsauce leads. Vsauce leads current. Yeah, rotation anti-clockwise. Vsauce is at the front of current. Vsauce leads current by phi radian. Vsauce leads current by phi radian. Vsauce at the front lah. Vsauce leads current by phi radian. Okay, Vsauce leads current by phi radian. So why Vsauce leads now? Because we have inductor L, yeah. Because that's the characteristic of L. It is the voltage leads current, yeah. Because we have L, That's why we have inductor. That's why it become the Vsauce leading. But it's not 90-degree because we have resistor, yeah. Understand? Okay, now RCL pula. Let's talk about RCL. RCL is combined between these two lah. We have RC and RL combined. RCL. So where is our resistor, class? Where is our resistor? Resistor is in phase. Our capacitor is current leading. So VC below. VL is voltage leading. So voltage at the top. Normally for this case is always VL at the top, VC below lah. Normally it's like this lah. Yeah, unless if you have other situation like let's say current is at the top, let's say current over here, then slightly change the graph, the phasor diagram. So VR is over here. For rotate, it's still rotation anti-clockwise. Always anti-clockwise, class. Always anti-clockwise. So if anti-clockwise, that means who is leading? VL is leading. VL should be over here. VL. VC is over here. Understand, class? Do you know how to change accordingly? Do you know? Okay. Why no respond one? Are you still there? That's why I don't really like online class, because I'm not sure you are listening or not, and no response. Yeah. So yeah. So VR at the top, and then VL over here, and VC. So are you understand, class? You know why change to this one?
Yes, sir.
Okay. Why only one voice only? Yeah. The others, what are you doing? Okay, never mind. Yeah, it's time wasting to think about it. So this one is cos. If this current is cos equation, cos omega t, then VR also cos omega t. But then the VC should be sine omega t, and then VL should be negative sine. Understand, class? If like this one is the current is using sine omega t, VR is using sine omega t, and then VL is cos omega t, and then VC is negative cos omega t. You understand this, class?
Yes, sir.
Yes, no need for me to write out all the equation over here. Yeah, so many things to explain. I hope that you can think about it. Yeah, you can process. No need to everything I need to say. You can think what, right? So this type of question. Yeah, he give the equation for I, and then ask you to build the equation for VR, build the equation for VL, build the equation for VC. Then you need to see lah. If give I is sine equation, then VL is cos, VC is negative cos. But if give the current is cos equation, then you need to change accordingly. You write the phasor diagram first, draw the phasor diagram first, then only you can identify what equation are they. Understand? Like this VL is negative sign, this one is VC is sign. You must know all these I's, LE, all these things, yeah, in phase. Okay, if you understand, it's easy. If you don't understand, then what to do, yeah, it become difficult. Okay, don't miss the class, yeah, no matter you have high headache or what, don't miss the class. Miss the class, then you should say sorry for yourself, not me, yeah, say sorry for yourself. Okay, so, and then one more thing, yeah, this one, it can be, you know, I want to redraw this one. So VL can be same length with VC. Let me draw it over here. VL can be same length as VC, or VL longer than VC, or VC longer than VL. Understand? So I give two cases here. I give one more cases over here. So it can be you know, VL at the top here, VC at the bottom here, and then VR here. Let me show the difference between these two. Or sometimes they can be same length. Same length, then same length. Then same length. That if same length is called resonance. Oh, today a lot of I've been teaching. Yeah. It can be same length. You know. Depend on how big is the capacitive reactance and inductive reactance, the XC and XL, depend on their value. So it can be same length also, can be VL equal to VC. Okay, let's look at these three conditions. This one is VL longer. If VL longer than VC, then how? Because we know this is opposite direction, right? Opposite, that means they cancel each other lah, isn't it? They minus each other. So after they minus, what do you get? After they minus each other, what do you get? You get how should I draw it? How should I draw it so that it's not messy? Yeah. Then it's VL minus VC. Understand, class? Because opposite direction they minus, right? So what is the resultant? This is the resultant. This is the V source. Understand? Then our phi is over here. Our phi is over here. Can you see or not? V source is over here. But if VC is longer, what happened? Then the graph go below. This become VC minus VL. So is the V source become over here. V source is over here. So what? Our phi is over here. Understand? If same length, how? Class, if same length, how? Then they totally cancel each other. So what happened? So our VR become V source. Our VR become V source. Understand? This is resonance. This resonance also I will talk about it some other time. Yeah, resonance I will talk about this resonance about some other time. Specific subtopic for this. Yeah, VR become V source. Now about this. So you can see the difference. If VL longer, it become V source leads current. If VC longer, is V source VR lead is current lead V source. Let me write it out. If like let me write it down. I should put this over here lah, right? Hey class, are you following?
Yes, sir.
If VL is longer, VL longer, then V source is leading. If VC longer, then current leading. See, so this one is V source leads current by phi radian. This one is current. You need to look at these two. You need to look at V source and current. Look at V source and current. This one, if VC longer, then is current lead V source. Remember, rotation anti-clockwise. Rotation anti-clockwise. Rotation anti-clockwise. Okay. So this one is let me write it down. So this one is current leads V source, okay, by 5 radian. Okay, current lead V source by 5 radian. Okay, so how to find the V source value? Also use Pythagoras theorem. This one, how to write it? So for both, I just say once V source is Pythagoras theorem. So you have to take VL minus VC or VC minus VL is the same, because you square. If you square the whole thing, it still become the same thing. Plus VR square. Pythagoras theorem lah. Pythagoras theorem. Understand? Pythagoras theorem. VR square root. Okay. Okay. So how about this? If I want to find impedance for the whole thing, impedance for the whole thing, Z. How? Also need the phasor diagram, and also need to see XL longer or XC longer, like that. Same thing lah. VR means we translate to R. VL translate to XL. VC translate to XC. Translate to XC. So this one is XL longer. So XL minus XC. Then here we have the Z. So Z. Okay. Z is equal to XL minus XC square, yeah, plus R square. Understand? Yeah. And then our phi is over here. So the power factor, you want to find the, you want to find what? You want to find phi, the phase angle between I and V source. You use cos phi lah. It's the same thing. Yeah. For this diagram also is R over Z. Cos phi is R over Z also. Adjacent over hypotenuse, isn't it? R over Z. Correct or not, class? Okay. So if RC circuit is RXC, if RL is RXL, if RCL is then you, because they opposite direction, then you need to minus XL or minus XC, or XC minus XL square plus R square over square root. Okay, class, that's all lah. That's all. Very simple. Yeah. So you cannot say Z equal to XL plus XC plus R. No, this is only for DC only. You do like that. If AC, you need to do phasor diagram. Yeah, this is what we call phasor diagram. Okay, because why? Because why? Because VL and VC and VR, they have different phase. So you need to do Pythagoras theorem. Cannot just add up. They have different phase. That's the reason. Sometimes they ask you to explain, because they have different phase. Yeah, all of them. Okay. Anything else? You understand? So okay. So I taught you everything already. Yeah, starting from here, I taught you everything already. So 6.3 haven't. I've done 6.2. Yeah, I done teaching what is the difference between RCL and RCL. So this RCL can have two cases. It can either V source leads current or current leads V source. If same, how? If same, then is if same, if VL and VC same, then is in phase. V source in phase with current. So for this one, the phi is 0 radian. Then that is, if phi is 0 radian, that means what? I is in phase with V source. Yeah, V source is in phase with I. If phi is 0, Phi is 0, then is in phase. V source. And also we can say if we also can also translate it to, you know, cos phi is what? Let me change it. So what is this again? So again, wait, let me write. See. Never mind. Programming problem again. So okay, I want to change it. I see. You see what happening there? Don't know whether you, never mind lah, not important. Okay. So one more thing, kalau phi is 0, another thing is cos phi equal to, if cos 0 equal to what? 1. The power factor when resonance happens, that means resonance happens when XL equal to XC, or we can say VL equal to VC lah. Yeah, resonance happen, cos phi power factor equal to 1, phi equal to 0, current in phase with V source. In fact, V source, the VR equal to V source. Because why? Because VL and VC being cancelled already. You understand? Cancelled totally. So another thing is you can translate this to you know, let me current, and then we have here we have R, can translate it to XL, XC kan. This totally cancel. When this totally they are equal, they totally cancel. So R is a Z. Because why R equal to Z? Because no more XL and XC. They are equal, right? XL and XC no more. So the total impedance is the R itself. It's the R itself only. So R equal to Z. So that is when resonance happen. Resonance. Okay. R equal to Z. VR equal to V source, and then power factor equal to 1. All these are very important points. Yeah. So the current in phase with V source. In phase. What more did I haven't teach you? I think I taught you everything really. Okay, class. So RCF can have 3 conditions. Can either VL longer than VC. If VL longer than VC, then V source leading. If VC longer than VL, then it's current leading. If VL equal to VC, then become resonance. Then it's in phase. Become in phase. You only have resistor now. The Z equal to resistor. Then it's in phase. So you have three conditions. Okay. This one should put over here. Then okay lah. That's all lah. Yeah, that's all. Yeah. For RCRL and RCL. Okay, for tutorial question, I already teach the class before. Yeah, so all that I already have YouTube videos. So I want you to watch my video. Yeah, I already have. You see. Okay. Wait. I think I stopped recording for a while. Yeah, stop recording.